Hey guys, this video is going to focus on how to graph compound inequalities or compound linear inequalities. So we're talking about graphing lines. So here we're given an example where we're given two different linear inequalities here. So I have 2x plus y is less than or equal to 4, and then I have x minus 1 is greater than 0. And we need to graph their intersection. Now that is one thing that we do need to become familiar with when it comes to these examples. A lot of these examples, they're going to either give you the word and, or they're going to give you the word or. And when they give you the word and, I know it's a very common word, but the word and in respect to compound inequalities actually has the meaning of an intersection. So we are going to want to graph the intersection of these two here. Had we been given the word or, that would be a union of the two graphs. So we're going to talk about that more in a little bit here. Otherwise, there's a couple of other things that we do need to be aware of when it does come to graphing linear inequalities. And those two main things, the big difference between inequalities and just linear equations, excuse me, is the kind of line that we're going to have represent. If you're given examples that have the less than or the greater, excuse me, the less than or the greater than symbol, when it comes to graphing your line, it needs to be represented by a dashed line. But if you're given the less than or equal to or greater than or equal to symbols, that represents a solid line in respect to your graph here. Having the equal than symbols attached to it, that means you can actually equal the graph and you can include the graph, which is why it's solid. But if it's less than it or greater than it, it can't actually equal the line. So that's what a dashed line represents. A dashed line means it can't actually equal that line, but it could above or below it, just depending on the symbol. And if it has the equal then attached to it, it can include that line, which is why we fill it in. Also, when it comes to inequalities, we're normally shading an area. So our line is just not our solution. The space above or below the line could be our solution space. And that just depends on, again, what our symbol is. So if you have the greater than or equal to symbols, you are going to be shading above the line. Or if you have the less than or equal to symbols, you are going to be shading below the line. And again, I'll go into a little bit more detail when we get to that part in this problem here. But we are tasked to graph these compound inequalities, which means that if I have to graph these two here, the easiest thing is to put them in slope-intercept form. That is the typical way to graph most linear equations here. So taking a look at my first example, 2x plus y is less than or equal to 4. The first thing I'm going to do is solve this equation, this inequality for y. So I'm going to get y by itself, and I'm going to do so by subtracting 2x on each side. That's going to make that cancel on the left-hand side, giving me that y is less than or equal to negative 2x plus 4. Taking a look at the equation that I have over here on the right-hand side, so this is x minus 1 is greater than 0. One thing that we do need to keep in mind about this one here is this is one of our special lines. So an x equals or an x greater than, this is a vertical line. So that's one of those special lines. Your special lines are either your vertical line or it's your horizontal line. If you have an x equals, it's a vertical line. If you have a y equals, it's a horizontal line. And you have to know that coming into this problem. Otherwise, we do need our variable by itself. So I would start by adding 1 on both sides, giving me that x is greater than 1. Now I'm actually ready to graph these here. So I'm going to go ahead and create my coordinate system. And I'm going to work first on graphing my first equation here that says y is less than or equal to negative 2x plus 4. Always start by plotting your y-intercept. So our y-intercept is a positive 4. So from the origin, go straight up 4 and plot your y-intercept. From your y-intercept, you then look at your slope, and your slope is your coefficient of x. So here our slope is a negative 2. So from that y-intercept up to over 1 in the negative direction, or down to over 1. So negative slope needs to follow this typical direction here where it's falling to the right. Otherwise, we need to go ahead and draw our line connecting the dots, and before you do so, always make sure you pay attention to your symbol. We have the less than or equal than symbol, and because it has the equal than symbol attached to it, that does mean that we have a solid line when we draw it. We also want everything less than this line, so we want everything below it. So for right now, I'm just going to draw arrows pointing in that direction until I get the other graph drawn. So I'm going to move over and graph my other line here. So here I have x is greater than 1. And x equals is a vertical line at that specified number. So a positive 1 on my x-axis is right over here. So this is a vertical line. So I'm going to draw a vertical line, at 1, and I forgot to look at my symbol before I connected the dots here. Looking at my symbol, this is a greater than symbol, which means this needs to be a dashed line. So here we go, I'm going to create my dashed line. So greater than or equal to symbol, less than or equal to symbol, solid line, greater than or less than has to be a dashed line. And if we want everything greater than 1, so we want everything bigger than 1, so that means positive direction, which means we're shading to the right. Less than would have been shading to the left. So, because this is an and, this is an intersection, my solution space is the areas that intersect here. Where are they both shaded? So if I want everything under this line, but I want everything to the right of this, I'm actually looking at this space right over here as my solution space, because it has to be below this diagonal line, but it has to be to the right of this vertical line. So that is what my solution space would look like for this particular problem.